So we're going to present about the overview and challenges of building a blockchain in Elixir, like the talk says. And it's going to be more like overview, and we're going to give a quick overview of what we're doing and the problems we have. So who are we? This is Georgi, my colleague and Elixir developer in our team.
And this is Philipp. He's lead on the team, and he's / our blockchain expert. So first of all, let's give a brief overview of what this presentation is going to be. So first, Philipp is going to give you a quick overview of Aeternity's platform, what are its capabilities. Then I'll continue with the initial difficulties we had in our team building a blockchain on Elixir. And then we'll continue with why after like 7-ish months of development, we have discovered that Elixir is actually the right choice for building a blockchain implementation, and continue with what engineering designs we have adopted or we have implemented in the project.
So yeah, I'm going to start off to give an overview of the Aeternity platform and the Aeternity blockchain. So Aeternity is a public blockchain platform like Ethereum. It's still under development. And what we focus on is having a lot of first-class citizens into our blockchain and ease of use for developers. It's a proof-of-work public blockchain. We use Cycle proof of work by John Trump. And this is bound by memory latency, so there's not that much energy waste as you may know from Bitcoin or Ethereum. As a consensus algorithm in our blockchain, we don't use the Nakamoto consensus. We use a next-gen proposal from Cornell University. This focuses on, here's a nice image about it. We're going to make a key block every three minutes that is using normal proof of work like in Bitcoin. And this doesn't mine transactions. It just is a leader election. And the leader is allowed to generate blocks afterwards that don't generate any new income, but they makes the transaction secure and put them into the blockchain. One of the big things in Aeternity is the oracle, so we're going to have trusted oracles. Anybody can put real-world data in the blockchain, which is a huge problem right now in other blockchains. And you can make your smart contracts decide or make programs decide on this data. Yes. And the operator of an oracle, anybody can be operator, and you can set a fee. So I will only give you some data if you pay me some fee. For example, the New York Stock Exchange can make some money by giving out data they have. And we're going to have a naming system. This is like, currently in blockchain, you have all these cryptic long strings for addresses, and we're going to replace all of this with a name registration on the blockchain. So you can say, send me money to Philipp or Georgi, not to my cryptic address. This is this long and nobody can remember. And the most important thing about our platform is the smart contracts. We're going to have multiple languages supported. One thing is Solidity from Ethereum. It's supported, and then we're going to provide some more languages that are faster, they are checked, they are Turing complete and gas limited. And we're going to have a third language. This is really fast and amazing to use. So this is an example of our new languages. The first one is Sophia. It is ML or Reason ML dialect and pure functional language as smart contract language. And the lower one is Varna. This gets interpreted on run. And we're going to have state channel. This means you can execute your smart contracts off the actual blockchain with a lot of the security of the blockchain and have no limitations in how much transactions you do. Now to the Erlang and Elixir part. For our blockchain, we choose, or the team choose to use Erlang as a reference implementation. This is a little ahead of the Elixir team. In the implementation, we're going to have we have a really senior team to do this. And you can check it out. In the bottom of the slides, there's always the links, and it's all open source on our GitHub. And we have an Elixir implementation as well of our Aeternity protocol. And it is an alternative implementation of our protocol, and it has very Elixir-like code, so it's not a translation of Erlang. It's developed from scratch and without looking at the Erlang code, just at the protocol repository. And we focus on being easy for new developers to come into the project, and actually for non-Erlang developers, for any kind of developers to come in. And everything we do is open source on GitHub. You can find it out. Now I'm going to give over to Georgi for showing you the first or initial difficulties we had starting off with our team.
Yeah, so in this, I'm not going to speak about the difficulties we had in building a blockchain, but rather what difficulties we had implementing a blockchain with Elixir. So first of all, we had a few, having in mind that we were a team which a lot of people came from object-oriented programming, functional programming was actually some sort of a difficulty for us. It was new for us, the way to write stuff, the dynamic typing, and all the different new stuff that comes with Elixir and functional programming, like writing recursive functions, something that, yes, you can do it in the object-oriented, but it's not something you would do quite as a lot as you do in the functional programming. Since we started like quarter of 2017, last quarter, we started with earlier Elixir, and which was pre 1.6, where we didn't have formatting. There wasn't much guidelines we had to follow, and coming from object-oriented programming, we were scattered to see, okay, what style should we continue on? We had different opinions, and this was some difficulties we had to overcome. Of course, there were few community standards at that point. Yes, we had some GitHub stuff that we could use, and mainly we were sourcing those as things to follow. Of course, very few blockchains were made in Elixir or Erlang, so we didn't have something to look at and say, okay, that's a good thing, we can implement it, or this is something that we can do better. We were actually pioneers in doing this in Elixir, and even less available native blockchain libraries, because doing a blockchain implementation, you have to write a lot of binaries or some blockchain specific things that there weren't so many libraries to use. Additionally, it's hard on Windows due to the dependencies of some of the dependencies we use, but mainly we work on Linux, so that's fine for us. And then, okay, since we have developed this for quite some time, we have seen that Elixir is actually the right choice, and Philipp is going to continue with telling you why that actually is.
So since a few months, we are sure Elixir is the right choice for our project, and we're happy that we choose it. The first point we set as initial difficulty, but it turned out to be great, functional programming. The team loves it, and we're quite familiar with it now. And actually, the modern language design of Elixir, it's very approachable to new developers we onboard to the team, and everybody who's just having a look at it, it's very quick to show some things, how we implemented them. And yeah, the syntax is really nice. What's perfect for blockchain is concurrency by design, because blockchain is concurrent by design. It's a peer-to-peer application. You're going to have a lot of messages coming in and data being requested and data being processed and verified. This can all happen in separate threads, and this is amazing to do in Elixir or any Beam-based language. Elixir provides us with really powerful binary support. This is also great for blockchain usage, because for once you want to have the data as small as possible, so binary data formats are really good for this. And all the cryptographic functions we use, such as hashes and digital signatures, are based on binary data. Sure, every project in the Erlang and Elixir space uses Gen servers to have stateful components. We use them a lot as well for like caching some data where we have huge gigabytes of data for blockchain stored on disk, and the one we want to access very quickly, we have in state, and also some things like what peers are we currently connected to with our connection protocol. Then other great feature in Elixir that we use are the umbrella projects. We have split up our applications in like our core development application, which is the blockchain. And then we have some client and server functionality to call other other nodes in our blockchain environment, and also some data. And we provide some server for other clients to call us, and it's a REST API for user interaction. And then we have some utility split up. It's all in umbrella projects, so we can test it separately. This is really good for us. And surely everybody loves the rock solid beam, the great fault tolerancy, strong concurrency by design, the attack-proof network support, and all of this. It's great. And I want to focus a little on the dependency system. This has not gained much attention yet, and we actually use a lot of ways to integrate other people's code and other people's software into our project. For example, our proof of work algorithm, we initially tried it with a NIF implementation, but it runs, depending on the system, for 1 to 10 seconds each execution. So NIFs did crash fairly often, and it was not very nice to handle these errors. So we're going to call this the native binaries that are there via lexec, or in our case, Elixir, exec. We use the implementation of the noise protocol. It's an Erlang implementation that Aeternity did write. So we're just going to call the Erlang code there. We use a Merkle-Patricia tree library. This is an Elixir implementation, so we have also 2 different kinds of code included. Then we use Anacle. It's a crypto library, or libsodium implementation, of Anacle. And therefore, we use the Erlang NIF wrapper for this. And we use RocksDB Rust dependency for our database. And this is actually Elixir NIF wrapper. Yeah, so this is why Elixir was a great choice for us, because we have all of these things to do. And now Georgi is going to show you some things that we worked around in Elixir and made it great for us in daily use.
Yeah. So let's showcase those patterns that we have used. So first of all, we have tried to make a flat code structure. No deeply nested code, make it easy, which would make it easy for new people to come, look at the code and get it into their head quite fast. Writing it with the intention to make it easy to be read by other people. Gen servers, as Philipp said, is something that we use quite often for state models. And coming from the previous talk, I think you already know why pattern matching is quite nice. We find it really lovely in Elixir because we find it, of course, quite useful in a few cases that I'll showcase right here. So this is a simple function that would get a binary, and we can pattern match like the values that we actually need in this binary and build some sort of a structure that later we will use. A more different one would be this, where we would have all these functions that pattern match on the argument, and depending on the type, which is the argument, we're gonna get some type like the account, spinchex, or whatever. And of course, we can have a lot more like difficult-ish types of pattern matching. It's not always so simple. We can make it difficult if we want, and which in some cases it's okay, because this, if it wasn't pattern match, would be much more uglier. And if you're used to pattern matching, this wouldn't be so hard to read, mining the names of the variables. Then something we use is a validation interface. Having in mind we have a lot of transactions that we have to implement. Most of the transactions, in some case, they have a similar behavior. And you know it, we have behaviors in Elixir. So we can make some callbacks which are similar to all of our transactions, and then implement them in each of our transactions that we have, and make it easier for implementing new transactions and reading what actually a transaction does. So we have a few callbacks here that all of our transactions are going to implement. And going through one of our transaction type, which would be the quite common one, which would be a spend TX, so a transaction for spending money or sending money from me to you, or something like this. So first of all, we would have, let's say, I'll just showcase some of the functions. Like we have a validate, and the validate function takes the specified arguments, but depending on the type of TX, we would have a different validation because the transaction has different elements inside the structure. We would have a different pre-process check, and what this actually does is checking if the transaction can actually happen and is able to be executed on the chain state on the blockchain, and the chain state of the blockchain is somewhere where we hold all of our information for the blockchain. And then if everything goes fine, we can process it, add it to the blockchain, and yeah, everything's fine. Get the new status and update it. And of course, we have a lot of transactions, as you can see, and there are more to be added actually. So having in mind that we have so many transactions, this implementation of the callbacks makes it quite easy to make new transactions, because you know what functions you have to implement, and depending on what transaction you're doing, you would maybe do some slightly different stuff in the implementation of those functions. So yeah, that's mostly it. If you have any questions, we're here for you.
Thank you. We do have a little time for questions. Anyone? So one thing, sorry, that I will mention briefly, because like maybe it might be more useful considering the fact that we have this possibility, is that Philipp and Georgi will run a breakout session right after their talk about, I guess, more details around the technical implementation of all of this. That will run in parallel with the next talk, so you kind of have to pick and choose, sadly, but well, choice is better than not having choice, so that's okay. So even if you don't have questions now, maybe we can just, you can sort of like think about it, and if you're interested into the topic, can just go there. I did have one question though. This is just from me, so I'll just like pass the mic to myself. And so how big is the team total? Like how many people have picked up the language and everything, and how productive was it?
In our Erlang team, we're about 20 developers, but they work separate from the Elixir team. And in the Elixir team, we're about 12 people now, with actually 3 locations in Poland and 2 in Bulgaria. And yeah, in the beginning, we had some difficulties with the team because it was a fairly junior team, and now we started off, and everybody has gained a lot of traction, and it's actually working really good. It's
really good. It's a really good story. Yeah, thank you. Yeah. Okay. So yes.
So how long did the team get comfortable with change the paradigm, the language, and how long during this process was taken?
Okay. As a lot of us started out with Elixir, had very little experience, like between 1 year and 1 month of experience in Elixir. It took about I would say 2 to 3 months maybe to get started, to be productive, to work in common ways. And they were fairly junior, so we had some things to do, like define style guides for ourselves, to not get in our way, and agree on some things we want to do and some things we don't want to do. So I think about after 3 months, we were working really steady.
Yeah. So you mentioned something about doing transactions without the smart contracts thing, like you can do them off-chain or something like that?
Yes.
Can you explain what you mean by that and how that works and how that implementation might have been done? Or
so this is actually quite, right now work in progress. So I'm not too familiar with the details of the Elixir implementation, but I can tell you how it works in general. So I want to commit, like with Georgi, I buy coffee every day from him. So I go 1 or 2 times a day to him to buy a coffee. So we don't want to make a transaction on the blockchain that's going to cost a fee every time I buy a coffee. So I commit to, let's say for a month, I commit £60 or something to buy coffee with him. I'm going to commit this on the blockchain, and then we can just transact. I just pass the transaction to him. It's signed, so he has the guarantee that I cannot run away, and he can see that I locked up this money for him to use. And then I'm gonna spend, let's say, £50 of the money I locked up. So in the end, we're gonna make a calculation. He's gonna get the 50, I'm gonna get 10 back. So we only made 2 transactions we have to pay a fee for, and we can make unlimited transactions in between us. This is not only for spending money or using the spend transaction, is also for executing smart contracts. As you may have heard in Ethereum, it was a huge problem when this smart kitties, CryptoKitties thing was happening, that the blockchain was completely overloaded by transactions. This maybe won't happen depending on the implementation.
And also just last thing around sort of like, so the identity of the people using the blockchain, how is this organized in this particular
this is
blockchain?
Like in every blockchain, it's a cryptographic public-private key pair you have, and with the naming system, Georgi could register his name to be his public key, and then I can send to him with his name, but this is depending on how you want to do it.
Thank you. More? Oh, I was already there. It's okay. Exercise.
I saw the nice type specs in the examples in the slides. Do you have like dialyzer coverage? Do you use it much in your code base?
We had some problems starting with dialyzer. It showed a lot of stuff we didn't think it would show because we are actually quite strict on our type and type specification. And then we started like integrating it, but then it always have these lines, and we had a huge ignore file that we're updating all the time. And now we did throw it out again. We have a CI tool that's going to show us the dialyzer, but it's not going to break anything if it's not working perfectly, and we have a look manually from time to time.
Thank you. Okay.
Okay, thank you very much.
Thank you.